Dr. Ben Blair is an assistant professor of livestock population medicine here at Illinois in the College of Veterinary Medicine. His talk today will be focused on shaping workforce development in the delivery of animal care. So please welcome Dr. Blair to the podium.
Like many people before me, I am also a farm kid. So I grew up in a small town, Sparta, Illinois. Some of you probably know where that is. Again, had multiple livestock species. Swine was our primary focus. From 8 to 18, I was the farrowing lead on the farm, and I processed all pigs from day one on. So all castrations, vaccinations as an 8-year-old. It was quite a task. But that led me down this path that I'm on today. Started out this path, grew up down south, so I went to SIU Carbondale, so sorry Illinois. I went to Carbondale instead at first. It was much cheaper. Probably a good decision on my part. But I went into the engineering side of things because I thought engineering allows me to apply my love of math to solve problems. It was great. But my love of ag kept dragging me back into the ag side of things. Got into my junior year of undergrad, started doing the whole internship thing. Said if I could get a job at a John Deere or Case IH, I would stay as an engineer. If not, I'm not sure it kept me close enough to a farm to allow me to make the impact that I wanted to make. So I applied to vet school on a whim, got in randomly here at the U of I. So I did that for 4 years. So I went to vet school, graduated in 2016, and really thought I had a love of cow-calf medicine, wanted to go back and work with small producers on farms and see if I can make a meaningful change that way. Moved back home to the family farm, worked as a vet in a mixed animal practice for about a year. It was fun, I guess, but it really wasn't enacting the type of change that I wanted to see. Did a lot of what they would call fire engine practice. We go out and put out fires, but we don't make solutions. We don't solve things. We don't have that kind of power in those small practices. So randomly got a phone call from Jim Lowe, actually, who said, hey, I heard you don't like your job. I still to this day have no clue how he knew that. And he said, how about you come back and work for me for a couple of years? So I came back, did a PhD in epidemiology, but really focused on how do I use those skills and principles that I took in engineering school and apply them to an animal health setting. So all of my PhD research was focused on how do you use machine learning to make predictions on animal production, mainly sow production, to drive early detection of issues, whether that be disease or managerial issues. Upon finishing that PhD in 2021, I went to University of Minnesota for a bit to do a postdoc, but concurrently started my own consulting company where I was consulting for both tech startups, mainly based out of the Silicon Valley, San Francisco region. But then I also did a lot of consulting in the VC space. So mainly my largest client would have been Merck Animal Health Ventures. And I was helping them set up and build out their portfolio around computer vision and animal monitoring, as well as needleless vaccination, et cetera, et cetera, et cetera. So I was their lead researcher, oversaw all their clinical applications in multiple farms across the globe. Again, just like practice, a lot of fun, but they weren't my ideas. The other thing is the 160 nights a year on the road. My wife got a little tired of that, so she said I had to slow down. So again, same story. Jim Lowe called me one day and said, hey, I heard you're not terribly happy with your job. Still don't know how that happened, but it happened. He said, there's a posting that we're thinking about posting here. It'd be coming back to the university to be a professor in livestock population health. But I'm starting up this new thing called the Innovation Hub, Veterinary Innovation Hub, where we're trying to integrate tech with animal care and animal health. And I think you'd be perfect for that. So, long story short, applied, got the position. I've been here for about 16 months or so now. Started last August of 23. So what I want to take some time to talk about today is kind of, I'll say, a passion project of mine. When I came back to the university after spending a lot of time in the industry, working in these venture roles, what I realized when I got back was I hadn't spent any time thinking about how do I teach effectively, or how do I enact change within the students that I want to see, and how do I make them better and more equipped to go out and change the world in the way I think is best. I think many of us here today think that integration of AI, integration of tech, more reliance on data within the animal health space is the route forward, and I would agree with you. I'm here today to tell you that our veterinary students are not equipped yet to enact that change. And that's really what this project came based out of. When I came back, I got tasked with, again, as a good mentor, Jim just passed everything off to me. And so I got tasked with teaching all of the large animal electives in our veterinary curriculum. And if you know something about our veterinary students, we have about 160 students. There's probably 10 to 15 who materially care about agricultural animals, so swine or cattle. The rest see their path forward in small animal, perfectly acceptable and fine, but how do I get the most out of them in those classes that I'm teaching? So what I want to do today is cover a couple different concepts. One, I want to talk briefly and broadly about where I believe AI's role is in veterinary decision support. That can be in all aspects, right? It can be in clinical support. It can be in just administrative things. I think they all have value in this ecosystem. I want to explore the AI ecosystem within a veterinary practice, and what I mean by that is multifaceted, not only in a technology ecosystem, what kind of technologies are we implementing, but also what does the workplace look like? I don't think the traditional workplace of a veterinarian and a technician in these definitely large like swine practices or cattle practices are going to be the future forward. You're going to have veterinarians, you're going to have technicians, but you're also going to probably see people that look more like Varesh, one of our students in the Innovation Hub. You know, they have that engineering data science background. They're there to provide support in all these endeavors. We're going to talk a little bit, or probably a lot, about a veterinary-specific large language model that we've been developing within our college to aid students in all of their learning endeavors. And then we'll talk a little bit about what future things we see coming out of these projects. So let's just start by talking about the key challenges within the modern practice. So, large-scale swine production, dairy production, beef production, they're all producing mass amounts of data every day. That data can include production records, environmental records, it may be health observations from farm staff, we have nutritional information, but we produce all of this every day, and it goes into various streams and flows. And it leaves the veterinarian lacking a lot of context of what to do with that information. The other thing to be of note, we are currently in the midst of a veterinary shortage, especially in these rural farm animal practices. So time constraints are a serious concern, as well as labor shortages. And the threat of foreign animal disease, animal welfare never cease. And so those decisions that those veterinarians are forced to make every day have probably never been more important. And then on top of that, of course, we have all the regulatory documentation, you know, whether those be health papers or movement guidances that they must adhere to. The other thing, which I've already alluded to, veterinarians are lacking in some technical expertise. So the picture on the screen here is actually, this would be the original team that we developed at the Innovation Hub. So these are the first 5 guinea pigs or students that we recruited to come work for us. We now have 14 different engineering, data science, mechanical engineer, computer science students working, as well as veterinary students all together. But if we look at the average veterinarian in our class today, they are data illiterate and have an aversion to math. Our current program does not require any math to be completed in college prior to admissions, so we don't have that basic, like even college calculus. It is very much focused on the sciences, so chemistry, biology, et al. So most of our students that we see haven't had a real math class since AP Calculus in high school. It makes it quite challenging to do some data-centric activities without that basic understanding. So, what I want to talk about to start this, before we get into the projects, is kind of where I see AI's role in veterinary practice. So, I want to establish an important framework, and this is what I tell all of my students when I introduce AI in all classrooms, that I think AI in veterinary medicine is fundamentally about decision support. We're not trying to replace the veterinarian or replace the people on farms. We may try to make them more efficient in their labor, but I think the idea, and people have mentioned this earlier, the idea that we're going to replace the caretaker in a system that requires compassion is going to be difficult to sell to the general public. The most valuable AI systems don't make decisions for us, they make us better decision makers by providing 4 critical things: accurate, timely, and relevant information, all provided in a transparent manner. I think the transparency is an important piece, definitely when we're talking about a pool of people who are quasi-reluctant at times to the adoption of these technologies. Effective AI tools reduce the cognitive load by sorting through masses of data to identify patterns and abnormalities that merit attention. They present options with supporting evidence, allowing veterinarians to apply their expertise and judgment with better information. This partnership between AI and veterinarians enhances our capabilities rather than replaces them. Our unique skills and experiences are difficult to replace. In this environment, where both information overload and high-stake decisions are constant, AI should serve as a powerful amplifier of our expertise, helping us focus our attention where it can have the greatest impact. And I think that's an important piece as we start the early adoption of this kind of technology in the animal care space. So, again, talking about AI in veterinary medicine, I think it's important to highlight that these one-size-fits-all methodologies are probably not the right approach. It is really about providing an ecosystem of complementary technologies that provides enough information for the caregiver or the decision maker to make a better decision. So if we talk about just the kind of different technologies that exist, we can talk about machine learning, which excels in finding patterns in large data sets. It makes them valuable in predictive analytics, which we've alluded to some today already. We also have things like computer vision, which allows us to analyze the visual world. I think you're going to hear a little bit coming up here about using computer vision to look at swine behavior and other physical elements within the environment. We have natural language processing, which is what I'm going to talk about, so large language models. I think the reason we started with large language models, and we'll talk about this a little bit more, is because one thing that tends to lack in all these modalities is context. We provide data, but we don't provide any context around what that data means. So the user of that data needs context to see how it affects their decision making. We also have IoT and sensors. That's pretty self-explanatory, just helping us collect things like environmental data, et cetera. And then actually, originally on this schedule, one of my coworkers, Dr. Heidi Phillips, was going to come here and talk about her work in augmented and virtual reality. But ultimately, both of those technologies are emerging as a way to overlay data on a physical world. And all those can be used to help us in either observation of animals, assessment of animals, and or during procedures. So let's get into a little bit of what we are doing in regards to our large language model at the Veterinary Innovation Hub. So again, like I said, when I came back from my stint in industry, what I realized was I did not enjoy standing in front of a room lecturing to people. So what I'm doing today is not what I normally do in a classroom. I don't like it. I don't think students learn well from it. I prefer an active modality of learning. So I started from the beginning saying I'm going to gamify my classroom. Everything we do is going to be based around they go learn information. They can collect information any way they need. I don't need to be the person providing information, right? There's Google, there's large language models for that. I want to help them apply that information. So this project was a way for us to aid me in that gamification of the classroom. What we did is utilized open source models, so namely Llama 3.2, to generate a contextual large language model using only veterinary specific content. We did that using a RAG architecture, or retrieval augmented generation architecture, meaning that all of our responses are only generated from that veterinary specific literature. This is important, right? Because the last thing we want is our large language models to hallucinate information when trying to provide information back to students. So, the other thing that's important with RAG is we can use RAG to analyze patient records to generate rapid preliminary assessments, and we thought that had some value in this model. We can also integrate this model into existing workflows within the university. So we don't want to replace workflows, we want to integrate our technology within those workflows. And finally, the reason we thought RAG was important, because again, it provides that contextual awareness of veterinary medicine. And so ultimately allowed us to build a model that we believe thought a little bit more like a veterinarian. There are some key focus areas when we were building this model. Of course, retrieval is of utmost importance. So we wanted to ensure that we retrieved accurate documentation so we could provide that transparency in all of our answers, and I'll show you why that's important here in a minute. We also wanted to design prompt engineering that allowed for unique prompts to guide the large language model and ensuring context-aware retrieval responses. So a good example of this, when we first started, we thought we really figured it out. We were on it. We had a model that was working. We could ask it questions. They would give us responses. Except the common response was, take the dog to the vet. It's not an appropriate response if you're a veterinary student, right? That's not the answer you're looking for. So through prompt engineering, we've kind of highlighted that and fixed those flaws to provide the level of context that we're after. Additionally, the prompt engineering has been really important because one thing we've tried to ensure in this model, has anybody here used large language models? I hope a lot of people here have. The prompt that you use a lot of times dictates the kind of response that you get back, right? And in students, we felt like maybe that wasn't always the fairest way to do that. Meaning that if you're a really good student, you could probably write a really good prompt and get a really good response back. And if you were a bad student and wrote a really bad prompt, this technology isn't going to help you excel and move forward, right? Because you're limited by that prompt. And so we just spent a lot of time through prompt engineering trying to normalize the information that the students are inputting into the system so that we ensure that we get a very standardized and similar response back to any queries along a similar subject matter. The other thing that's important here has been evaluation. So we've evaluated this model, a million different ways. But we really focused in on, of course, just general accuracy. We'll talk a little bit more about that, but also, again, the user interface, or the user experience is of utmost important to us. And then latency and scalability. We currently have about 600 vet students. Our first initial run of this, we had a small model running on a small server, and we would crash it about every 20 students that used it. So that's not very useful either, so we had to fix that. So the other thing that's important, we talk about retrieval. Our retrieval architecture is kind of multifaceted. We started with vector embeddings, and so that ultimately converts text into numerical representations so that we can find similar documentations to what the prompts have stated. These work fairly well. However, they have their flaws. We've also implemented Solr, which is very similar to like an Elasticsearch, but it's a search engine that indexes and retrieves documentation using keyword-based and advanced search techniques. But ultimately what we've fell on is kind of a hybrid model of the two. So we're using both solar and vector embeddings to allow accurate retrieval. Okay, so let's talk a little bit about how the model is working currently and how we generated it. So we talked a little bit about the general architecture of that, and we can talk deeply about that if you want to afterwards, or you can ask Varesh to sit in the back of the room. He's kind of the guy that masterminded the whole architecture piece, so you can ask him. But within our model, what we think makes our model special is our data source. So I know Jim talked about this previously and kind of stole some of my thunder, but our data is unique to our organization. So our data includes everything that would make up a normal veterinary curriculum. So it includes all lecture materials, lecture transcripts, PowerPoints, textbooks, assessments. We also have over 1 million clinical case records from the Veterinary Teaching Hospital and associated research papers. The other interesting part about our retrieval is that because we're highlighting transparency in everything we do, our retrieval fetches 5 documents for every response. So if a student asks a question about canine kidney disease, they guarantee a response from a textbook, a lecture, and a research article. And then it provides 2 additional resources that are similar to the keywords found in their prompt. We currently have 3 different, 3 different versions of our model working. The one that's the furthest, of course, is just the general chat bot, which I'll display for you here shortly. But it would simply, the student can ask a question, receive a response, including all those cited resources. We're working on one that would be more Socratic interaction. And so instead of the chatbot ever replying with answers, direct answers to their problems, it would provide additional questions for them to think about. So for example, in that similar case where we said, hey, I want to know more about canine kidney disease, it wouldn't respond with, here's everything you need to know about canine kidney disease. It would instead reply with, hey, do you understand the basic filtration mechanism of the kidney? And they could answer, and based on their response, it would pose further questions to gauge their understanding of those things. We think this really helps drive engagement, and in the short little bits that I've used this and enrolled this in some of my classes, it really allows students to interact with the technology instead of just being passively engaged with it. And then finally, probably my favorite portion of this has been, we have a model that generates live interactive case studies. So if I want to teach a course today and I want to talk about GI disease in swine, and I want to hit these 3 key learning objectives, I can highlight what those 3 key learning objectives are. I can ask for it to generate me a case, and then I can send that case to the students to use so that they can interact live and get haptic feedback on what their decisions are within the case. So if their first decision was, hey, I think we should run oral fluids looking for PED in a barn, it will reply with what the outcome of that decision is, and then step by step through the whole process. Again, it's really all about gamifying that experience for the students so we drive material engagement, but also deep understanding of those things in an interactive and fun way. Evaluation-wise, generally speaking, accuracy, we've evaluated in 3 different ways. Those would be through just basic true-false questions, multiple choice questions, and then descriptive questions. We currently score about a 98% on an example national licensing examination. So if anybody's ever taken that exam, it's not a lot of fun. 98% would be well above the average veterinarian that takes that exam. As far as what it scores on true-false portions of the veterinary curriculum, we're about 85% accurate on that. We're currently looking back at why that occurs, and there tends to be just a little lapse in its understanding subtle context from professors' question writing. And then finally, on descriptive, we built a rubric to grade that, and we're currently scoring about an 80% on those descriptive answers. Now, in saying all that, accuracy is not the main goal of this project. While we think it's important to drive appropriate accuracy of this model, we don't think accuracy is what's going to set us apart. We can compete with the ChatGPTs or the Gronks or the name the large language model of the world, and we make slight improvements on very specific veterinary questions. But I think it's just temporary, right? They're going to leapfrog us with their next iteration of their model. Where we're trying to set this apart is not in accuracy. Accuracy is a benchmark. We have to hit a certain level of accuracy to implement this tool. But we really think what sets us apart is the user interaction piece. So one of our future works is actually, we're going to spend a lot of time trying to understand what students want from this tool. So in a Socratic interaction, how deep should that first question be? What should that first question look like? Where do you want us to lead you in that first question? And those are the things that we think will set us apart in education, not just that it's right all the time. Thinking a little bit further about future works with this, we are working on a memory map, and so that should theoretically help us with some of our retrieval, but it also has some impacts to our curricular mapping, and so we're trying to find those glaring gaps within our curriculum and where students fail most often. We are working on a custom embedding model to improve the capture of veterinary medical text, again, trying to improve slight gains in accuracy of our responses. I've already mentioned user surveys, and then of course we're going to try to roll out our Socratic model here by the end of the semester, and then the live case-based thing, I think me and Jim are thinking we're going to teach with that next fall in one of our core classes. So, I don't know if this will work or not. We're going to try it. This is roughly what our current iteration of this model looks like. It's nothing fancy. It's very straightforward. But as you can see, we would have question, a response, and then some of the literature that would be associated with that. I'm going to see if I can pull this up. I don't know if I can do this. Okay. So, simply, I'm sure everybody's seen these before because I'm sure most people here have interacted with LLMs. But simply speaking, just so you can see it work, and we're not lying to you, we didn't generate that using large language models. I'll prove it. Because I can't see it. So I asked, can you tell me more about fluid therapy in a dog with shock? There's its response. Of course, contextually speaking, that should be at some level. We're actually working on making that a deeper level, so we're expanding. Currently, based on the kind of our hosting, we're only limited to 300 words responses. That's soon going to change to a full page, so it gives them a little more room to respond. Additionally, it's so hard to drive this way. We have the associated links with that. Now I got to find out how to get off of here. Okay. So that's where we're at today. We have this working chat bot. Soon we'll have this Socratic teaching model that should. So in that case, when it's just tell me more about that, about fluid therapy and shock, it might ask a question like, well, what is shock, right? And the student would say, well, shock is this. And it would correct that and ask another further question to force students to declare what they know and find those gaps in their education. Like Jim said, we are currently working on trying to figure out the right modality in which to capture all those interactive data pieces. It is student data, so we have to be a little careful with it, from what they tell me. So, but we think it also provides huge benefits in terms of what we as a college understand about what we're teaching. Again, you can't you can't implement change if you don't measure the outcome. The outcome being how well do students understand the material. Now I lost the mouse. There it is. Okay. So, what are some benefits of utilizing AI in the classroom? So, I think it really allows us to personalize the learning education. As Jim mentioned earlier, with those interactive case-based type learning activities, if all we're trying to do is teach them the fundamentals about how the kidney works, irregardless if they like cattle, swine, snakes, etc., they can pick a species of their choosing and they can provide a case that adheres to our learning objectives. So they can still learn about the loop of Henle in a goat kidney versus me learning about it in a cattle kidney, right? Those fundamentals are still true, but it allows them to personalize the education that they have. I think it enhances their access to information. For me, when I was in school, I was in that Google era. So in undergrad, it was very much like a don't use Google, right? Google's bad, don't use Google. And then quickly it became you Googled everything, right? And everybody Googles everything. I think large language models in education are kind of there right now, right? You hear a lot of professors on campus, don't use LLMs, it's cheating. Well, I get it. There's unethical uses of LLMs. However, it is also a really good way to collect a lot of information in a very quick manner. And I think we should reward that in some sense within some of our students. We already talked about improved clinical simulations, helps provide some complex problem solving. So we do this in every one of my classes. My classes are not focused on content. They are focused on problem solving. Again, we can find content. It's all over the internet. What makes it different? Are you able to contextualize that content, use it to make your life better, and advance decision making? Efficiency in a task, that's self-explanatory. I think a good one here, and probably smart for the whole group, is I think utilization of these technologies really allows for preparation of an AI-driven veterinary practice. You can't ask a veterinarian to use AI if they've never seen it, right? It's hard to trust something you've never used. Definitely used in a very formatted, confined setting. I give them training wheels on AI, right? I provide a safe environment for them to go use and explore AI's use, and then I'll tell them, hey, that's not ethical use, that's great, good job. If they learn to do that their first year in practice, when they're just trying to figure out how not to lose their license, it doesn't work out really well. Kind of just covered that. But ultimately, preparation for AI-driven world focuses on familiarity with AI tools, understanding AI's role, not only in your practice or in your system, but what's appropriate uses, what's inappropriate uses. And then it's ultimately learning how to collaborate effectively with that AI. Some implementation considerations I think to think about. These are true not only for our educational use here, but I think it's true for all AI uses in all of agriculture. I think it's important to start with high impact, low risk applications. We're doing this in classroom settings. So we have a little bit of say of what's good and bad. It's kind of low risk in that regard, right? If the AI gets it wrong in my class, it's not the end of the world. I think emphasizing transparency and explainability is an important piece. I think one of the big flaws with AI acceptance is the fact that sometimes it lacks that transparency and users don't see how that information can be better used to make them better decision makers. It can't be a black box. We have to provide them information regarding how that rationale or use is being completed. I think it has to integrate with existing workflows. If you have to do more work to implement AI, nobody's ever going to use it. And I think we have to build AI literacy across the industry. I don't mean probably technically speaking. I think it's what's appropriate uses. How can you use it? How can we use AI to make our day better? And then, of course, we got to measure outcomes. And then, of course, all this was not without challenges and limitations. We've talked long and hard about this. The data quality within animal ag, I'll be frank, kind of sucks, right? Every large system is using 9 or 10 different softwares. They're not interoperable. Everything we just heard about FAIR, that doesn't exist in most pig farms today. We have 9 pieces of software to do 9 different things, and none of them speak. It has to integrate with those legacy systems. So with us, it has to integrate within our educational system. But if you're using AI in a swine farm, it has to integrate with all their systems. It has to have explainability. It has to have some validation in different environments. That's true with our model as well. So we're implementing this in small classrooms first, so 20 students-ish. We're going to implement it in a large-scale lecture hall next semester, next fall. It might fall flat on its face. We're going to find out. AI is true, though, right? You have to try it out in different environments to see if it works. And then, of course, there's some cost and technical barriers. I think I'm running out of time, so I'll just end it here. If you have any questions, feel free to email me. The link there, that's for our Veterinary Innovation Hub, but I'll be willing to take any questions. Thank you.
So I was wondering if you had any thoughts on like a similar model, but from the farmer perspective, just because a lot of the challenges you talked about at the beginning of your presentation about, the lack of veterinarians and those sorts of things. I know in my family's beef farm, the vet that we always used to go to, they don't even do large animal anymore. So I didn't know if you had thoughts on if it would be something relatively similar kind of in your workspace to help farmers make decisions about veterinary topics?
It's a good question. So I'll say this. We started this project with education in mind because we had a good understanding of the entire system, right? We work in it every day. We also work in farms every day. And so long term, the goal of this is actually to implement this more into a field setting. Education gives us a great place to try things out, right? Again, it is that controlled environment. It's hard to get 20 farmers in a room to use something for hours on end, weeks after week after week, right? It's much easier to do that with students. And so our initial goal of this project is purely educational, but long-term, we see it has real implications, not only to farmers, to veterinarians, to even some of the farm staff on some of the swine farms, right? Everybody can always use a little more information, a little more education, a little more context. And we think these large language models that are built off of contextual information or concepts that are true to their environment provide real value for all levels through the animal ag industry.
Thank you.
It's a very good presentation. Thank you for that. And I'm really interested because we actually are I'm from Purdue, and me, Dr. Puckmaster, and our team actually doing the reverse thing. So instead of asking GPT the question, GPT asks us some questions, and we are doing it for record keeping for field metadata. So my question is, the AI models are probabilistic, they are not deterministic, so they keep changing the language or the way they talk to us. So do you face any problem for that? Like if you ask a question, like you just asked a question, and after a few moments, if you ask the same question, it will give you information, but in a different way. Do you feel it's a problem, or how do you handle that?
Yeah, no, it is definitely a problem, right? That's why a lot of our evaluation of this is not necessarily just truly on accuracy. Some of it's consistency in response. And the way we're attempting to do that, at least in the short term, is through kind of hidden prompts. And so we've provided, yes, the student can apply a prompt, but that is just part of a larger prompt that we've already established that drives the level of information and how we want the information to be fed back to the student to try to normalize the responses of that LLM. But definitely an issue that we're facing and something that we're very sensitive to, right? Because again, if we believe this should be something that helps people, it has to be an accessible tool regardless of the level or the question that you ask. And so something that we're definitely interested in moving forward and trying to ensure that our model does.
You mentioned benchmarking in your presentation, and maybe this is broader than your current project, but you think about these kind of capabilities emerging, is there an opportunity for benchmarking to help standardize and accelerate the deployment of these models across the broader space of veterinary medicine or in animal production?
Yeah, I mean, so that's something that me and Varesh talk about probably every week. You know, there is no defined evaluation criteria in which to judge a model by today. And so we've talked about posing one, and then we kind of backed off of it because of the work it takes to pose a benchmarking, standardization format. But I do think benchmarking of these in terms of what accuracy needs to be usable, as well as what's consistency in responses, all those things, there should be a standard in which we should set moving forward so that we ensure that all usable technologies at least meet those standards to speed up implementation in the field. I completely agree.
I have a follow-up is related to, there's a lot of implications in what we're describing today. We talk about, you're describing the practice of veterinary medicine, but others have been talking about the particular production systems. I was wondering, does production system knowledge, how does that fit into the curriculums you're developing? And I know there's a lot of variations in what people do in terms of different ways of executing, but is that a factor in deciding some of these?
Yeah, it's a great question. So that was actually the initial reason why I wanted to build this. So like I said, I teach these large animal electives for our veterinary students. 80% of them, 90% of them have never been on a pig farm before. So they lack the true context to which to make these decisions. This model is built in a way that helps provide some of that context of how pig farms work, right? What's basic production look like? What's economics look like within a pig farm? And so it allows them to quickly and tangibly access information regarding the fundamental basics of a pig farm, right? And so it provides context. I think that's the biggest value in these large language models, isn't necessarily that they can provide answers really fast. They allow us to take a lot of information from different data flows and build context to the problem we're trying to solve. And so, yeah, to your point, that was the initial goal of this, was not necessarily to say, here's how you treat kidney disease. It was to provide the student more context around a system, whether it be swine or even a dog, right? It's just providing context for that system. Thank you.
Thank you.
Okay, Lee.
Dr. Blair, can you just touch on the students that you're working with in this project and kind of how they work and speed a little bit for the sake of this room?
Yep. So I probably should have alluded to this more because they are a pivotal part of all of this. So like she said, this would not be possible by me alone. It is because of the work and efforts of all the members on our team. Our team is composed purely of graduate students and undergraduate students who are looking for extra work. We put out a job posting this fall for a few positions. We had 176 applicants in about 24 hours from campus. That was a lot of fun doing interviews for that many people. Luckily, I had team leads, so I made them do most of it, so that was great. But, so those students would be composed of, we have industrial engineers, mechanical engineers, computer scientists, data scientists, and then we have some veterinary students. We also think the component that we have this multidisciplinary kind of format for veterinary students to go interact with is extremely valuable for their training, right? I'll tell you one of the biggest challenges I faced when I was in industry working with these startups is that they possessed one of two types of knowledge. They were extremely technical and lacked all kind of biological or system context, or they were the opposite. They were a bunch of veterinarians who thought they were going to do something really cool with tech and had no idea how it worked. So like Jared mentioned earlier, he spent his time at Pork Board being a translator. That's what I did for 3 years. I translated between veterinarians and engineers because they did not talk well with each other. And so I think providing a format or a forum in which veterinarians and engineers can interact and engage makes better veterinarians in the future. But yeah, our team's extremely important. I'm happy to work with them. It's probably the best part of my day to get back in some of those engineering roots. But I guess, like I said, Varesh is here. He's our team lead on the LLM project. And happy to keep moving forward and hopefully keep growing. Yeah, so far. It depends if Jim's in the office or not. Last week he was gone to Napa, and it was fantastic. I got work done. No, I do, because I think what I've always wanted was this intersection of animal health and tech, right? I get to do animal health, which I love. I grew up on a pig farm. I love the health and welfare of animals. That's what drives me. But I want to do it in a forward-thinking way, and this role allows me to do that. I get to try new things, do new things, and they're my thoughts, not other people's thoughts, right? That was kind of the downside of industry. It was fun, but it was very much like, here's my idea, you go make it work. And I'm like, well, it might not ever work. And they're like, well, it's my idea, you figure it out. And so being back here is kind of nice in that regards, that I get to do all those things that I love in one spot.